Lesson 3.1 is analyzing percents of numbers. So on page 135, looking at a little bit of vocabulary here, things we've already talked about. Number 1, a blank is a ratio in which the first term is compared to 100. So that would be a percent. Number 2, a ratio that relates two quantities with different units of measure. And that would be a rate. Different units of measure, so like 60 miles per 2 gallons, for example, would be a rate. More commonly, we've talked about unit rates, where we'd actually divide that out and get 30 miles per gallon, something like that. Number 3, a statement that two ratios are equal. That would be a proportion. And number 4, the relationship 3 students out of 5 students is an example of that would be ratio, comparing two things. Okay, so that's just a little bit of vocabulary review for you. If we look at the next part here, 5 through 7, write each number in two equivalent forms as a fraction, decimal, or percent. So whatever it's not, they want the other two. Okay? So for example, number 5 is a decimal, they want the fraction and the percent. So if we look at number 5, if we think about this decimal, the decimal is 29 hundredths, so that as a fraction would be 29 hundredths, 29 over 100. Always with fractions, we're going to try to reduce if we can. This one cannot be reduced, so that would be our fraction answer. And then one more thing they want is the percent. And remember, a percent is a number out of 100, so we literally have 29 out of 100, and so that means 29%. Okay, to help you remember that, cent has to do with 100, like 100 cents in a dollar, 100 years in a century. They say 100 legs on a centipede. I've not counted them yet. So number 6, 35%. If we're going to write that as a fraction, that would be 35 over 100. This time we can reduce. Those are both divisible by 5. And that would be 7 out of 20. 7/20ths, we can't reduce any further. Our decimal would be 0 and 35 hundredths, or just 35 hundredths. Sometimes we put the 0 so we can see the decimal point easier. You can get that straight from our fraction here. Fraction was 35 hundredths, decimal would also be 35 hundredths. Another option you may remember we've talked about is if you take your decimal point, so in this case 35%, the decimal's after the 5. If you move your decimal 2 places to the left, that also changes your percent to a decimal. And think about what we're doing is we're putting it over 100. Well, you divide by 100, divide by 10 moves your decimal 1 spot, dividing by 100 moves your decimal 2 places. Dividing by 1,000 would move it 3 places. So again, just another option for you to change to a decimal. So we'll look at number 7. We've got 2/5. So this time they've given us a fraction, and they want the decimal and the percent. So a few options for this one. One option is if you can get your denominator to a 10, 100, or 1,000. In this case, actually could multiply both of these by 2, and that'd be 4/10, and then our decimal would be 4/10. Okay, that's one option. Another option, we've been talking a lot about getting a denominator of 100, and this is kind of a 2-for-1 here. If you get a denominator of 100, that's 40 over 100. So decimal would be 40 hundredths. Understand the 0 is optional. 0 would not have to be there. And then the other thing is the percent, which if we did it this way, we could possibly see easier that this would be 40%. Up here, we talked about you could move your decimal 2 places. We'd have to add a 0, and that would be 40% as well. Page 137, Jamie's older brother and his 3 friends want to split the cost of lunch. They also want to leave a 15% to 20% tip. How much should each person pay? This problem, the wording gets people sometimes. Okay, think about this. So this actually would be 4 people. Some people look at this problem, they see the 3, and they think 3 people, and they just, kind of rush through it a little bit, okay? It's Jamie's older brother and his 3 friends, so 1 plus 3, that's 4. Okay, so if you look at the receipt here, apparently we're not worrying about who actually bought what, so if you bought the cheaper items, I guess you're out of luck here because they're splitting it evenly. Okay, so total is $78. That's before the tip. So the tip is something we're adding on for service for the waiter or waitress. And it says, 15 to 20% tip. Probably just go one way or the other. Either figure out the 15% tip or figure out the 20% tip. Okay, we're not going to figure like a 17.5% tip. Yes. So in order to find our tip, let's say we're going to do a 20% tip. What we need to do is find what 20% of $78 is. So like we talked about earlier, 20%, we can change that to a decimal. Move the decimal 2 places to the left. You could change it to a fraction if you wanted to as well. Okay, so that's 20 hundredths or 2 tenths. The word of generally means multiply. So if we multiply that by 78, that would be a 20% tip. So this is 15.6, which means $15.60 tip. And then what happens is the tip gets added on to the bill. So if we add that on to $78, would be $93.60. And then they're going to split that equally, which means we're going to divide. So you could take $93.60 divided by 4. When you divide that out, it's 23.4. So $23.40 each if we split this evenly. Okay, again, not really necessarily fair to the people that got the cheaper items here, but that's what they told us to do, so that's what we can do. We could do the same idea with the 15% tip. 15% tip, if you do 0.15 times 78, that's $11.70. Add that on would be $89.70, and then divide that by 4 would be $22.43. So not a huge difference, about $1 less with a 15% tip versus a 20% tip. If we look at example 1, Diego starts a 12-hour road trip with his phone's battery charge at 75%. Given his normal usage, will his phone last the whole trip? And explain. So you can see 100% charge is 15 hours. What we're trying to figure out is the 75% charge, how long that's going to last. One option you can do is to do a proportion. So 75%, that's like 75 out of 100, and we're trying to figure out how many that would be compared to 15. It's kind of like a part compared to a whole. 75 is part of 100, and X is part of 15. If you do it this way, if you're solving for x, you could say the x is being divided by 15, so you could multiply by 15 on both sides. That's like 15 over 1, so those would cancel. Over on the left side, you do 75 times 15 would be 1,125, and then divide by 100 would be 11 and 25 hundredths. So that means it would be 11.25 hours. He's got a 12-hour trip, so it's not going to be quite enough for lasting the whole trip. A different option you guys could do for this problem, probably a simpler approach, would be you could figure out what is 75% of 15. 15 was the full amount. We're trying to find 75% of that. And so if you change 75% to a decimal and multiply that, you will get 11 and 25 hundredths. So a little bit quicker route, if that makes sense for you. If not, you're welcome to do the proportion like the book did. So to try it, we've got a similar problem. Kita's phone had a fully charged battery. With normal usage, her phone will last 18 hours. How much time is left on Kita's phone battery with 12% charge remaining? Alright, so once again, the 18 hours is the full amount. We're trying to figure out the 12% charge. So one option, we could figure out what's 12% of 18. Again, move the decimal over on the 12%, and then of means multiply. So if you multiply, that would be 2.16, so 2 and 1600ths hours with our 12% charge. Again, the other option you have, like the book's doing, is you can do a proportion here. 12%, that's 12 out of 100, and we're trying to figure out that's how much out of 18. If you do it this way, you could say they're dividing by 18, so you could multiply by 18 on both sides of the equation. Again, that's like 18 over 1, and work that out, multiply, divide by 100, and you'll get the same answer. Okay, so two different ways that you can do these problems. Example 2, a full set of adult teeth includes 160% as many teeth as a full set of baby teeth. How many teeth are there in a full set of adult teeth? Okay, so you can see from the picture there are 20 baby teeth. We know the adult teeth, it says 160% more, or 160% as many. So we know that means that we're going to have more teeth. Makes sense. Your mouth gets bigger, and so you have more teeth that fill in the gaps here. So one way you could do this is figure out 160% of 20. So if you move your decimal 2 spots here, it's 1.6 or 1.60. Anytime you have over 100%, you're going to have a number before the decimal point, and when you multiply that out, you'll get 32. So that's 32 adult teeth. Again, the other option, like the book did, you could do a proportion. 160%, 160 over 100, and we're trying to find the number compared to 20. In this case, since 160% is bigger than 100%, this t should be bigger than 20. They're dividing, so you multiply by 20 on both sides. You get 3,200 over 100. Divide that out, and you get 32. Again, whichever way you want to do that is fine. So look at example 3. What is the approximate distance in miles from Earth to the Moon? So you can see Earth to the Sun is 93 million miles. Earth to the Moon is 0.27% of the distance between the Sun and the Earth. Okay, so again, for this problem, we could figure out what is 0.27% of 93 million. Understand 0.27%, that's still a percent. We still have to move our decimal 2 places to the left. So that'd be 27 ten-thousandths times 93 million. And we should get the same answer as the book here. 251,100. Okay. Still a pretty good distance, but nothing compared to the distance to the sun. And again, the other option the book's showing you is the proportion. So 0.27%, so 0.27 over 100 equals x over 93 million. And if you multiply by 93 million on both sides, again, it's like 93 million over 1. Work that out, and you'll get the same answer. So if we look at the try it, these are already kind of set up the way I was mentioning that the book didn't do these, but again, whichever way you want to work these out is fine. So part A, one option would be moving your decimal 2 places to the left, which means we have to annex or add a 0 here, so that would be 8 ten-thousandths. Of means times, and this is a pretty small decimal, so our number is going to be getting quite a bit smaller, and this would be 576 thousandths when you work that out. Okay, again, you could do a proportion as well, which would be 800ths over 100 equals x over 720. You'll get the same answer. So for part B, 162.5%, we're taking over 100%, so our answer is going to be bigger than what we started with. Okay. One common misconception people have when they're working with percents, they think when they change it to a decimal, the decimal always goes right before the first number. It's not the case. A lot of what you guys initially worked with, you were doing that, but if we got over 100%, that's not going to be the case with those problems. Work that out would be 325, and that seems reasonable. 162.5%, that's over 1.5 times the 200. 1.5 times would be 300, so just a little bit more than that. And part C. Part C, once again, moving the decimal 2 places would be 3 thousandths times 60, and that would be 1800ths, or 0 and 1800ths.